Here's the new short stroke crank. Lots of extra metal and seriously overbalanced. So after taking a pretty serious hunk of metal away, we're just pretty much in static balance now. So it's time to mount it up and do a dynamic balance on it next. Here it is set up in the balancing machine. We'll see how much it shakes. That's pretty darn good for the first try. Shouldn't take much more work now at all. Here's a shot of the balancer screen, and you can see where the heavy spots are on two planes of the crank. Let's figure out where the heavy spots are exactly and where to remove metal, and we'll try to get this error down to near zero. Okay, so now how do we go about balancing this? First we install a trial weight, which, as you can see, I have 4 magnets stuck to the counterbalance here. The weight and position of those magnets is entered into the program. 12 grams of weight, and they're at 225 degrees. These weights will be used by the computer so that it knows how much change a weight makes in that position. So the computer now knows how much it's shaking with that weight installed. and we'll save that value. Now we're going to move our weights over to the other plane. Still the same 12 grams of weight, still at the same degree of revolution. And we'll find out how much that affects the balance. And we will save that entry. Then we'll take the weights off altogether. And we'll spin it up. And you see the balance without the trial weights is much better. It's really pretty good balance right where it is. But we'll try to go ahead and reduce the error. So we will save that. And now the program figures up how much weight, and it tells us to remove 20.73 grams at 272 degrees on the near counterweight, and 8 grams at 143 degrees on the far counterweight. So that's 20.19 at 272 and 8.25 at 143. So I'll mark this 272 degrees. So right here we need to remove 20 grams. And at 143 degrees, right here we need to remove 8 grams. So we'll give that a shot and we'll try it again. And this process will be repeated probably 3 or 4 times until we have it worked down to a better balance factor. Or a better balance, I should say. We're not changing the factor. Okay, since I really don't want to remove more than necessary from this expensive chunk of metal, I've removed about half of what was called for by machining this little flat here and this little flat here. And as you can see, we have improved the balance. Over what it was before. Now I'll go ahead and start over and put trial weights on it. Take 2 readings and get a new set of numbers. Okay, what have we ended up with? Got a crankshaft with a small cut here, small cut here, and a small cut here. Small cut here, and a small cut here. And what we are ended up with is a crankshaft with no perceptible shake. And balance errors that are far better than necessary. And I would call it ready to go.